Okay. All right, and now, again, just though I'm recording, remember you've got the CFA on Monday, no calculator, pre-test on Tuesday. You'll have the entire period. You will be allowed a calculator on that one. That's not for a grade. Both days, though, please bring your charged Chromebook. All this information is on the website. Okay, so our next unit, we're going to go ahead and get into absolute value equations. All right, so warm up number one, it says, and this is absolute value. It's denoted by those two long bars. Okay. So, yeah. Okay. Unfortunately, that's got to be warning number one. Okay. Okay. Remember, we can't have that. In fact, remember, go ahead and close your laptops because we don't need that. Okay. All right. So, what is absolute value anyway? Jackson. It's the distance from zero on a number line. So if I'm going to take the absolute value of, for example, 7, what would you tell me that is? That's 7. But what about the absolute value of a negative 7? That's also 7. Because absolute value, it kind of addresses the idea that we don't have negative distances in real life. If I were to go ahead and throw a ball, I'm not going to say I threw it a negative 20 feet to somebody. That doesn't make sense with the way we think of things. So that's what absolute value is going to do for us. Now, number two, if the absolute value of x equals negative 4, what are the possible values of x that'll make this true? Okay, so I heard 4. Okay, who said? Okay, Carlos, okay. Like Jackson's like him. Okay. All right. Anybody else got an idea? Is 4 correct? What do you mean nothing? Okay, what's the one thing that absolute value cannot produce? Cannot produce a negative. Absolute value will only ever produce a positive result. Okay. Hello. Brianna? Yes, ma'am. Coach Liao? Okay. Want to speak with you? Okay. All right, so that's absolutely correct. None. X cannot be negative 4 units away from 0 on the number line. So if you're ever solving an equation where you have an absolute value is equal to a negative number, you can stop right there. There is no solution. It is not going to happen. Okay, so how are we going to solve absolute value equations? Well, I'm glad you asked. Okay, number one, we're going to isolate the absolute value expression. Number two, create two cases. Set the inside equal to both the positive and negative value of the number on the opposite side of the equal sign. So I'll explain what that means in just a second. Number three, solve both equations and then check for extraneous solutions. So let's stop for just a quick second because vocabulary is going to be really important. Extraneous simply means solutions that do not work in the original equation. Okay, put simply, they are a false solution. Okay, they're a false solution. So you somehow get a result, some value, but if I were to plug it back in, it does not make it true. We call that extraneous. Okay, so let's get right to it. All right, solve each equation. Be sure to check for extraneous. Now, here's what we were referring to. We want to isolate the absolute value notation. So anything outside these bars, if anything's multiplied or divided against it, added or subtracted, we want to get rid of all that material. Once it's like this, then we're going to go ahead and set up our two equations. Okay. Now, the first equation is going to look exactly like what you see here. All you're going to do is drop the bars. So no absolute value. So I'm going to go ahead and say that x minus 9 is equal to 5. Okay. Now the other one, I'm still going to go ahead and drop the bars, but that's where the constant on the other side is going to come in super useful. I'm going to say x minus 9 is equal to negative 5. So this is what it was saying back in step 2. We're dropping the absolute value. One equation is as you see it. The other one is the opposite of your constant. Okay. Now we'll go back and kind of revisit this, like why are we doing this in the first place? All right, but these are super easy. What's 5 plus 9? Was it? 14. Okay. Thought I heard something else. I just want to go ahead and make sure. So 14 is a possible solution. Now, we do want to go ahead and check it because it could be false, could be extraneous. And then over here, I'm going to do the exact same thing, but what's a negative 5 plus 9 this time? So x equals 4. Okay. Now, we're going to go ahead and check these. If they work, then we're going to go ahead and write these in a roster. Basically, those squiggly brackets, and we actually saw that earlier in the week and last week as well. So let's see. Let's plug 14 in. So the absolute value of 14 minus 9, okay, will that give me 5? Well, what's the absolute value? Well, what's 14 minus 9 to begin with? 5. Will the absolute value of 5 give me 5? Yes. 14 is perfect. Okay. Now let's do the same thing for the other one. The absolute value, x minus 9, so I'm going to say 4 minus 9. Okay. 4 minus 9 is a what? Negative 5. Will the absolute value of negative 5 give me 5? Yes. Both of these satisfy the equation, so they're both solutions. So we're going to go ahead and write them as a roster. I'm going to put it as a squiggly bracket, 4, comma 14. Now, like always, you want to go ahead and write your answers in ascending order, 4 and then 14. I'm not going to be that big a stickler. If you put 14, comma 4, you're going to be fine. Okay? Because as far as I'm concerned, you're demonstrating your knowledge of how to solve one of these. Okay? But let's kind of go back and see, why did I have to create 2 equations in the first place? Because you'll notice I can go ahead and put in 2 different values but get the same outcome. Okay. See, both a positive 5 and a negative 5, they both gave me the same output. So we've got 2 different values, so that's why we have to create 2 different equations. Also, just think about a number line. You've got 2 different distances, one positive, one negative, from 0. Okay. Easy? Okay, well, let's try another one here. Okay, number 4, 3 equals the absolute value of 2k plus 7. Okay, let me get back to my pen. Okay, so there is nothing to isolate. The absolute value bars are already by themselves. What's my first equation? What's the one thing I'd drop for the first one? Just get rid of the bars. So 3 is equal to 2k plus 7. Okay, that's my first equation. What changes for the second? Okay, and what's the other equation? Okay, the only thing that changes in the second equation is you take the opposite of your constant. So negative 3 is equal to 2k plus 7. Okay. This is how we solve an absolute value equation, by creating 2 separate equations. And then it's just like we were doing earlier in the week. How do I get rid of the 7? Okay, subtract it. So 3 minus 7 is a negative 4, is equal to 2k. If I divide by 2, what is my first solution? Okay, negative 2. So that's my first possible solution. Okay. Now we do the same thing for the other one. But this time when I subtract 7, negative 3 minus 7 is a negative 10. Equals 2k. So what's k? Divided by 2, k is negative 5. And you'll notice I'm not showing the movement of these terms. Okay. If anybody would like me to go back and start doing that, please let me know. That is not an issue. Okay, so let's try this. Let's plug it back in. So I've got the absolute value of 2 times k. So let's do this first one, negative 2, then plus 7. Okay, so this is going to be the absolute value. I need a negative 4 plus 7. 3. So the absolute value of 3 is 3. Okay, that's exactly what I should be getting. The negative 2 is good. See, the check should only be a very small portion of what you're doing. It shouldn't take up a whole lot of time. And you don't want it to. You just want to guarantee you got the right answer. Okay, let's try that other one now. So negative 5. So the absolute value of 2 times negative 5 plus 7. Okay. So negative 10 plus 7, what's that? Negative 3. And the absolute value of negative 3 is 3. So negative 5 works. They are both solutions. So I'm going to go ahead and write them out. Now, which one is the smaller? The negative 5. So I'm going to say negative 5, negative 2. There we go. That's it. Okay. That's all there is to it. Yes, sir. Sure. Okay. All right. How many folks remember this? Good, 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 good. Okay, well, let's go ahead and try one more, and then we'll go ahead and stop there. We'll go ahead and take a look at the review again, in case you wanted to ask questions about those problems. So the absolute value of y minus 1 plus 17 equals 23. Okay, I'm ready to get my two equations. Or am I? Why, what's wrong? There you go. The absolute value isn't isolated. See, I've still got this term. Okay, anything added or subtracted, multiplied or divided against the bars, we've got to get rid of. So the absolute value of y minus 1 should equal, what's a 23 minus 17? 6. Okay. Yeah, you just, I think you gave everybody a... Okay, let's try this then. Okay. Okay, Miles, what's the rest of your number? 47728. There we go. Okay, continue. Okay, restroom. That's okay. We'll deal with it. It's all good. So let's send you to the second east. You're good to go. Okay, so I'll deal with this in just a second. Okay. That's okay. That's not a problem. That's not a problem. You got this. Okay. All right. Anyways, now what do I do? Now I'm ready to create my equations. So my first equation is what? Y minus 1 equals 6. Equation 2. Y minus 1 equals negative 6. There you go. And this one's going to be really easy to go ahead and solve, because if I add 1 here, y is equal to 7. Okay, here, negative 6 plus 1 is a negative 5. Now, just because of the time, I'm going to go ahead and say, yes, they do both work, but you can check that. So I'm going to write it as a roster, negative 5, 7. Okay, there we go. All right, absolute value equations. Now, those are some pretty basic ones. Next time when I see you, we'll go ahead and start looking at some that probably have some fractional values, things of that nature. You know, we'll start building on it. But are there any questions so far? Fantastic. So make sure, hang on to these notes, okay, through the weekend. Maybe put it in the binder, folder, whatever the case is. Bring them back on Monday, okay? Let's go ahead and put this to the side. Go ahead and pull out that review from yesterday. Okay. All right. So here's that review from yesterday. Remember, this is what's going to go ahead and get you ready for that CFA. Now, if you didn't notice, let me go ahead and show you the class website real quick. I did it earlier this morning. Okay, here's Algebra 2 pre-AP. You'll notice this very first listing. Okay. All right, it's not letting me click on it or something going on, but it's posted. Okay, so you'll be able to pull that up. Okay, so the key is on the website. Okay. So, Carlos. Actually, I was going to say let's just work some problems together. Yeah. So were there any problems as you were looking at this yesterday that you got stuck? You're thinking, I'm not sure what to do. Yes, ma'am. On the back? What number? 7? Okay. So I think we did 7A, right? Yeah. Okay. So let's go ahead. Let's work 7B. Okay. So we're dealing with the quadratic. I want to find the vertices, the zeros, and the y-intercepts. Okay. Now remember, basically, the zeros, those are x-intercepts. When you're finding the x and the y-intercepts, just think one of your values always has to be 0. So if I want the x-intercepts at 0 for y, if I want the y-intercept, x is going to be 0. Okay. Now let's go ahead and start with the vertex, though. This was the general form for vertex form. A times x minus h squared plus k. So the vertex was going to be found at hk. Remember, whatever's with x, you got to take the opposite value, but whatever's outside, that is going to remain the same. So given this, what's my vertex? This is my h, this is my k. I just heard somebody start to say it. Is it 3 or negative 3? Negative 3, and then what? Negative 32. Okay. 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 All right. And we're all sorted. It's all good. Sure. All right. So we got the vertex. Now let's go ahead and find the zeros. Okay. That means I want to solve for x. Okay. So I'm going to take my equation here. Y equals 2 times x plus 3 squared minus 32. If I'm looking for the values of x, they're going to make this true. I'm going to change y to 0. 2 times x plus 3 squared minus 32, just like that. Okay. Now, think about what we did yesterday. What's my first step? Remember, my goal is to completely simplify, isolate the x so that x equals. Okay, what's that? I heard somebody say something. Is that Emery? Who's talking? Okay, let's get rid of that 32. We're going to add 32. So this time I'll go ahead and show it. Plus 32. So 32 is equal to 2 times x plus 3 squared. Got it? There you go. Yeah, you're good. I don't think you affected that. That's weird that that many people are now overtime. But okay. Don't forget this. All right. Now what? Okay, sir. Okay, not yet. There's something I got to do before we do that. Divide by 2. I've got to completely isolate this squared group before I go after that 2 right there. Okay, so what's half of 32? 16. So 16 is equal to x plus 3 squared. Once I've got that group by itself, now I'm going to take the square root. Remember, a square and a square root, they're going to cancel out. So what will x plus 3 equal? 4, but remember, we're forgetting something. Plus and minus. When you're solving an equation and have to take an even root, like a square root, fourth root, etc., you're going to want to put plus minus in front. Okay, so I'm going to use this to help me out. So either x plus 3 is going to equal a positive 4, or x plus 3 is going to equal a negative 4. Okay. In either case, let's subtract the 3. What's the first x? Okay, 1. Okay. And then if I subtract 3 here, we're getting closer. What kind of 7? Negative 7. Okay. So now I can go ahead and list. I've got 2 roots. Remember, those are my x-intercepts. The first one being x was 1, so that's 1, 0. And the second one was negative 7, so that's a negative 7, 0. There we go. I solved for x. I got 2 answers. Everybody okay with that? Now, the only thing left, I got to find the y-intercept. Okay. So let's go back to the original equation. Y is equal to 2 times x plus 3 squared minus 32. Okay. Now, you find the y-intercept when x is what? 0. So all I'm going to do is replace that with 0. So y equals 2 times 0 plus 3 squared minus 32. And then all we got to do is follow the order of operations. PEMDAS, please excuse my dear Aunt Sally. So we're going to have 2. 0 plus 3 is 3 squared minus 32. Okay. 3 squared. 9. Now I need 2 times 9. 18. Need to subtract the 32, a negative 14. So your y-intercept is going to be 0, negative 14. So there you go. I got the vertex, the y-intercept, and I got my roots. Now remember, if we go ahead and take this information and we go down to, like, say, number 8, right here, where we're looking at these quadratics, it says label the graph below with your key features. Okay, so let's see what we have here. Now, this point right here, okay, that's the what? That's the vertex. Okay. So the vertex is either the valley or the peak of your parabola, depending on how it opens. Now, this vertex in particular, does it contain a maximum or a minimum value? Contains a minimum because it's at the lowest point. Think of it at the bottom of a valley. So it contains a minimum. And every time we're talking about a minimum or a maximum, it's the y value of the vertex. Okay. What are these right here? Those are zeros. So I can call this one a 0. But besides zeros, they're both zeros, there's other names we could use. They are x-intercepts. Okay, they're also called solutions. You might also see them referred to as roots. Okay, but all those are synonymous with each other. Okay, what's this one right here? That's the y-intercept. Okay, now let me go ahead and show you something over here. Let's at least do this one more time. What's this right here? That's the vertex. Okay. Is that vertex a maximum or a minimum? It is a maximum. There you go. And remember, whether you're talking about a maximum or a minimum, it's the y value of your vertex. So I can go ahead and tell you that the maximum value for this function is 7. Okay. Because would everybody agree that the vertex is at a negative 3, 7? Remember, it's the y value of the vertex. That's your maximum or your minimum. So if we're looking over here, what's the minimum value for the one on the left? Negative 5. There you go. Because it looks like we have 4 negative 5. Now, I went a little further on that, but, okay. Ma'am, does that help out? Because you had originally asked about 7b. Is that good? All right. What else? Did anybody have the opportunity to take this home and look at it? Okay. So that's okay. I appreciate your honesty. But you've still got the entire weekend. We have tutorials on Monday morning, If you want to come in, that would be great. But they haven't called for us yet. It's going to be pretty quick, but we still have time. Is there anything else on this paper we'd like to take a look at? Yes. Number one. Let's look at number one. Number one is solving equations and inequalities. I'm going to leave that there for a second. Okay. Okay. So do you have a particular one you wanted to look at? I'm sorry? B? Okay. So I'm going to guess I know why she chose B, because we got fractions. Okay, that's perfectly fine. So I want to solve negative 4/3 times 9 minus 2k equals 1/2 times 1/3 k plus 1. Yeah, we got some fractions in there. Okay, don't let that intimidate you. Take it one step at a time. Remember, especially with the calculator, don't rush yourself. How am I going to get rid of these parentheses? We're going to have to distribute. Okay, so let's say I take negative 4/3 and I'm first going to multiply it by 9. Now, if you're just multiplying a fraction by a whole number, I'm going to take negative 4/3, but that whole number 9, I'm going to go ahead and put it over 1. Now, remember, you just multiply fractions straight across, but I can simplify on this one. Okay, what divides both 3 and 9? 3. So that would be a 1, that would be a 3. So it looks like we're going to get a negative 12. Okay. Now I need a negative 4/3 times a negative 2k. Now, the fact that it has a variable changes nothing. Okay. There's nothing that can simplify here, so what would that be? Oh, very close, not negative. Because remember, the two negatives are going to go what? Positive. So this is going to be plus 8/3 k. Or if you want to say 8k over 3, it's the same thing. Okay. But my point is, especially without the calculator, if it helps you to write this over to the side, absolutely do it. Okay. I'm going to have plenty of scratch paper. All right. Well, let's try the other side. Now here, what am I going to have to distribute? Okay, 1/2. So I'm first going to have to multiply 1/2 times a 1/3 k. Remember, to multiply fractions, it's straight across. So what's 1/2 times 1/3? That would be 1/6. And then don't forget about the k. And then what about 1/2 times 1? Okay, plus 1/2. Now I know that a lot of people are probably thinking the first step is to try to get rid of those fractions. You can't do that with the parentheses. You've got to drop the parentheses. Now I can multiply by some number, get rid of all of those fractions at one time. Now, the denominators are 3 and 6. The rule is multiply by the denominator to get rid of a fraction. But what do I do if there's more than one denominator? Okay. What you're looking for is a common multiple. What's the first number? We're not talking factors. Like 2 is a factor of 6. It divides in there. We're talking about a multiple. What's the first number that 3 and 6 will divide into? 6. But I've got to make sure to distribute it across the entire thing. So let's see, what's a 6 times a negative 12? Negative 72. Okay. Now, I got to multiply 6 times an 8/3 k. Do it just like we did before. So 1, 2, how many k's do I have? 16k. Equals. Okay. Now I want to go ahead and multiply. I need a 6 times 1/6 k. So that's just 1k. Plus, and then one more, half of 6. 3. Okay. So it took a couple of steps, but we made that equation look a lot nicer. Okay. Now, don't get me wrong. I mean, can we solve the equation with fractions? Yeah, it'd be super fun, right? Sure, yeah. Okay. But you'll make it easy on yourself. Now all we have to do is go ahead and just combine like terms, isolate, all that good stuff. So let's see here. Let's say I want to go ahead and subtract the k over. Okay. So 16K minus K. So I'll continue this up here. So we have a negative 72, okay, plus 15K is equal to, we already got rid of the K, so that's 3. Okay, what's my next step? Add the 72. Opposites cancel. 15K is equal to 75. Now what? Okay, so what is 75 divided by 15? There you go. So we don't need a calculator for that. We got a calculator in our head. Okay. I know a lot of people don't believe it when I say this, but calculators, computers, things of that nature, they're tools to make our lives easier, yes, but they can only do what they're told. I mean, unfortunately, we're getting to the point where AI is starting to think for itself, but let's put that outside for a little bit. Okay, let's leave that at the door. Okay, so you are smarter than a calculator. Trust me, you are. Okay, how are we doing? Bless you. Bless you. All right, so I'll tell you what. Let's go ahead and stop there. If you'll go ahead, they should be calling any second. Let's go ahead and get those calculators back up to the front, please.